Welcome to Wireless Future. I'm Eric Larsson and I'm here as always with Emil Björnsson. Hello Emil, how are you today?
I'm doing fine. So I try to stay healthy as usual.
It's great to know. Today we have a guest, Panos Papadimitratos, professor at KTH in Stockholm, Sweden, fellow of the IEEE, and an expert on network system security. So we're here to speak with you, Panos, about privacy and security challenges in wireless. So first, thanks for being with us today.
Thank you, gentlemen. It's a pleasure.
That's great.
It's an awesome opportunity to preach about security.
Mm-hmm. Would you like to tell us what are the challenges that we are facing today?
Well, as people can observe, wireless networks are everywhere or are getting everywhere. And the more applications they enable, the more useful they become, let's say in our everyday life, the more dependent we are on them. The less we can do without. And then this basically raises the stakes. This means that the appetite of those attackers that we have seen in the internet in other occasions can also grow. And the opportunities for them to compromise these wireless networks also increase. And you gentlemen, you discussed a number of issues a couple of episodes ago in this series. For example, you discussed about the fact that wireless communication per se can be vulnerable, can be easy to access, easy to interrupt, or easy to interject. So this is one of the starting points why there are many issues to address in wireless network security.
Sure. So, is it easy to defend against this?
Well, it's not easy because there's significant factors there that come into play. The challenge is more difficult because often these devices are limited in their resources and their capabilities. Why? Because we mean to deploy them, for example, in our physical spaces. They're supposed to be small footprint devices. It's what we call the Internet of Things. At the same time, they don't have the same protective measures that, for example, a powerful server somewhere in the internet could have. And then these devices are very close to their users. Mobile devices, for example, that we carry everywhere. So on the one hand, it's difficult to implement security and privacy given the limitations and given the exposure of those devices. On the other hand, for some of those, we rely more and more even for security purposes. So there's an even stronger need to be very careful and very diligent, actually, with security mechanisms and privacy protection mechanisms.
Right, so you're saying that, all these new devices, they are, to start with, they are close to the user, right? But also they are small and have limited computational capability, for example, so it is difficult to harden them against different types of security attacks. Could we get a little more specific on technical challenges here in terms of, for example, that you have worked in your lab a lot on cellular networks and also on vehicular communications. Could you describe to us a little bit more on the specific technical problems that we're facing here?
Yes, absolutely. So the reality is that, let me make a quick comment first, that on the one hand, we are interested in security. On the other hand, we cannot see this totally disconnected, or actually we have to see it together with privacy protection. And if we start with one great challenge ahead, let's consider that would be it. So let's consider mobile systems as they are now. You have cellular networks that provide high rate data connectivity practically everywhere. We have already some connected vehicles, and as time goes by, they will be more and more connected to the point that they will become eventually autonomous. We have users that go everywhere, whatever devices they carry, and they connect to different networks. And Wi-Fi is a leading technology. At the same time, on your computer, on your smartphone, on your car, you run all sorts of applications or services that are location-based, meaning they provide service to you given that they know your exact location. If you also consider that those that offer you network connectivity already know about your device, about you as a user, know apparently where you are, how you connect to their network, a great challenge ahead is that, great, we get all these fantastic services from this fancy ensemble of fancy technologies, but we leave behind a huge trace of information about ourselves. And at any point in time, someone could even know not only where we are and when we were there, but also what we are currently interested in. When, for example, we submit a query looking for, a restaurant or a pharmacy or whatever it is we're looking for. That's a great challenge. And the question is, who gets all this information that we leave behind, our devices leave behind? Could be the providers of the services, could be the networks we're connected to, but it could also be anyone that is having their own network of devices overhearing our communication. So it's a major challenge to reduce this footprint, protect to the extent possible the privacy of the users of such great services and technologies.
Mm. So privacy of location seems to be a major issue here, right? So I think, one thing that we'd like to know a little more in detail, and perhaps Emil, you could lead that part of the discussion, would be to know more about the technological solutions that are out there and that are envisioned in order to deal with this challenge.
Yes, so I suppose that the military have a lot of ways of protecting their communications, but they are also sort of people who are trained to how to utilize their devices, and they have all of the technology that is required to protect themselves. But we sort of are looking for, we would like to use these services, we would like to benefit from them, but at the same time sort of protect our privacy. So are there any technological solutions that can enable us to use the services but also get the security and privacy in a good way?
Mm-hmm. So let me first point out that one aspect of privacy is per se a security property. So one thing that we can do is to protect confidentiality of communications. Meaning, what we can do is we can hide the content, right, over whatever channel we are communicating at any given point in time, and that's one step ahead. And I recall also an earlier discussion you had. You were discussing about physical layer security, how you can, for example, form the transmissions or encode in ways that transmissions are less perceptible or not perceptible at all by those who shouldn't. Yet you also discussed whether encryption could be a great solution to this all. Indeed, it's a very useful tool, but what is interesting is that even if we encrypt, for example, the communication from our mobile to the cell tower, from our laptop to the Wi-Fi access point, that gives significant protection and actually happens nowadays. Nonetheless, as we move from network to network, or as we connect from service to service, even though we have this confidentiality, still the identity of our machine or the type of communication or the time and location is perceptible not only by the networks, but even by someone that is overhearing. I mean, the same thing will be true in a short while when, let's say, our car are moving around, and at the same time they're transmitting information about themselves to protect traffic safety, protect ourselves from other cars, for example, or from pedestrians. It suffices to just collect this information and just realize that, okay, that person, that vehicle has been traversing this part of the city at that time, and so on and so forth.
So is this only on like patterns on the population level that we can see that there are a lot of people at this time in this part of the city and not in that part, or can you also identify individuals with these type of patterns?
Oh, you can actually. It depends on where you stand and what effort you make and what privileges you have to begin with when you collect this information. So, for example, if you're a cellular provider, you need to know where are your mobile phones. But then there are legal reasons to protect this information and not disclose it, right? But if you can infer this information because you have a network deployed out there and you're just listening, and you can find out now individual traces of devices. Maybe you don't know yet who the user is, but then by, for example, observing the same trace day in, day out, you can tell where is the starting point in the morning, where is the end point in the afternoon, and vice versa. You can see if it crosses with significant, landmarks, something a bit out of the ordinary, right? And then in the end, by basing these observations on the one hand in repetition and all sorts of inferences, and at the same time potentially connecting this to other databases you might get access to. I mean, nowadays you can query almost everything over the internet. You could in the end identify who the person is, where they live, where they work, what are they doing at any given point in time, this period of their life. Maybe they're visiting a doctor, a medical doctor, to get some therapy, if they pass from a given place. There are even suggestions that you can even infer other philosophical or religious interests, right? Let's say they pass from a mosque or a synagogue every given day of the week. Well, then you can infer, or from a church, you can infer who they are at a very profound level. That's really the challenge, that once you have precise location information, then you can infer much more based on that.
Yeah, so every time I sit in the car and started, my Apple Watch tried to guess where I'm heading and saying, oh, it takes 10 or 15 minutes to this and that place. And I suppose then that that's because I'm sort of connecting my phone to the car, but someone else could essentially try to do the same type of predictions based on external observations than
yes.
on me.
For example, you could even think now, I mean, if we want to make the situation a little more scary, I mean, let me clarify that we're not trying to paint a bleak picture. We're not trying to scare people off. On the contrary, we want to raise awareness. But let's say that I am your service provider, right? And now you start your application, and then you realize that you need something, and maybe you ask through the voice activated interface in your car, can you please find the best and closest original Italian pizzeria or something, right? So this doesn't hurt, but let's use this as an example. Then that moment I know that you like pizza. Then you say, hey, okay, find now the one that is offering, let's say, gluten-free options in the. Now I know that you have some other constraint or some other need, and we can keep building on this type of queries. And now I do know everything about what you need, where you need it. If I were not to be fully trusted, if I were to be as a provider honest but curious, meaning I want to figure out what all these users of mine really need. Why? Because maybe I want to try to sell them products or sell products of my affiliates and so on and so forth, right? Then the challenge is even more significant. So you get the service, you are happy, but at the same time you disclose quite a lot of information about yourself. And if you were not to be respected by the provider, then that information could stay in the internet forever.
Yeah,
and that's a significant challenge too.
Yeah, and this seems to be sort of a general trend that a lot of services are free to the user, except for that you give away a lot of information about yourself so they can sell advertisements or in other way make money out of you indirectly. Then I've also seen this trend in the last few years about like there's privacy modes in browsers and things like that. Is there a way of building the systems to still keep some kind of privacy? Can we evolve them going forward?
There are many tools, and the scope is quite broad. Since you mentioned the private mode of a browser, well, that's an interesting option. Nonetheless, it does not really hide your content, the data you send over the internet. The only thing it does is that it shields you from the unwanted, I wouldn't call it intruder, but let's say someone that sees your browser and tries to look what you have been looking at, then they won't see the latest searches of yours. Nonetheless, if someone is dropping, observing your network traffic, then they could know. But let's say in the context of mobile and wireless. So one main consideration could be how do you design from the beginning these mobile services or these mobile networks, if you wish, with a mindset to protect to a certain extent privacy. And one thing that you want to achieve is, for example, unlinkability, meaning can you make communications that are secure, not linkable, meaning you observe one message, you observe a second message, a third message. Can you make it difficult for anyone to tell that message 1 and message 2 and message 3 were from the same user, the same sender? Another thing you can try to do is to remove as much identifying information from any interaction over the network. For example, take away the identity of the user altogether, or replace it with something that doesn't tell much. It's a pseudonym, and then even change from one identity over time to another, so that you have both this hiding of the identity and the unlinkability, hopefully. That's one thing you can do on the side of of the client, if you wish, or the device, and then you can also start thinking, well, what about these honest but curious service providers? Can I do anything? Well, you can think that maybe you can assign this task of, let's say, anonymization, if you wish, to a special entity. The question would be, if you don't trust the service provider to begin with, why would you trust someone else to do it for you? Wouldn't you just give the same power, let's say, to the anonymizer, whatever that server is, that service is, or even more? Let's say, imagine now you have one entity that collects all queries and tries to anonymize them and then submit them to the right service providers, and then get all the answers. Now, that entity knows about everything and all service providers, so it's an even more significant challenge. So one can start thinking, well, can you empower the users even more, let them help each other in a collaborative way and reduce their exposure? And these are, let's say, basic ideas that one can work with, along with some sort of blurring of the information, meaning, you don't submit a query with your precise location, but you say, hey, okay, I want something in a given zone. That means you don't reveal exactly where you are, but still you get useful information. Or, I throw in too many ideas now. Or you rely on some help from some infrastructure where you and others actually mix, and then you try to hide temporarily in the crowd, and then you change your identity if you wish, and then you continue, so that you, before and after that mixed zone, you are not easy to link or track. A lot of ideas there that can perhaps not provide full anonymity, full untraceability, but they can significantly reduce the footprint that we leave behind.
I see. So there seems to be a variety of different ways of approaching this issue. So I just have one final question on this topic. So do you think perfect privacy will ever be possible in these type of systems? I mean, theoretically speaking, or is this always going to be a game between cat and mouse game, like chasing each other?
I think the major challenge is that we are using these technologies, or we are building them, if you wish, so that we get some use out of. We need real-time information about where we are heading, and it unties our hands. I mean, it's very useful. So now, if we forgo all this, right, we disconnect. Apparently, that's the safest thing we can do. So this is the challenge. So if we need something useful, apparently we need to provide some information about what we need to a given system. But there are ways of making this from the get-go quite safe. Meaning, we build infrastructures that provide identity and credential management, that do that with the mindset of protecting the identities, anonymizing, pseudonymizing, providing unlinkability, and at the same time providing security, because we shouldn't forget that. And then we build services in ways that they also reduce the exposure. So if we put all these ideas together, we can limit the exposure to a very limited level, and raise the bar for anyone that wishes to track us, to need to have a huge investment, let's say, or compromise devices or parts of the system in order to do it. So I am not optimistic that there is perfect protection out there, because then if you want perfect protection, you disconnect. That's the But I'm optimistic that if people realize and they ask for privacy-enhancing versions of the services they get, and they're also careful with their choices, then we can be in a much better situation than we are now, together with some, of course, legal measures, because some aspects have to be also regulated, right, to motivate and ensure that such measures are in place.
Yeah, I suppose that someone needs to take the leading role in pushing towards finding this better trade-off between privacy and service quality, finding something that's better than today. So let's switch topic then, Eric.
Yeah, sure. I'd like to get back to the matter that we touched upon a little earlier on location and location privacy, and specifically in the context of satellite navigation systems and GNSS, GPS, for example. What are the issues in those systems?
That's directly related, since we're talking about location-based services. So apparently we need a good method to obtain that position. And then over the years, global navigation satellite systems have gotten a very nice spot in all this, because they're available much more broadly than other options nowadays, provide great accuracy, and then at the same time they provide you not only your location but a correction of your clock, of your time. So
right. So specifically thinking of attacks against these systems. I mean, spoofing, for example, of location and jamming of the entire signal. So not necessarily privacy as such, but rather security aspects.
Maybe you can explain first, how are we computing our location estimate from these satellites?
So, okay, absolutely. So, essentially, the satellites are on a well-defined trajectory. Right? So, we know at any point in time where they are, and they know themselves where they are. And then the signal basically allows the receiver to estimate its distance from not only one satellite, but many. And typically, there are depending on which constellation, which system that you're using, there are many visible, but for example, out of 7 or 8 visible, it suffices to have at least 4, so that you can compute your current location, knowing the position of the satellite and the distance from that given satellite, 4 of those or more, and then you solve a system of equations. It could be overdetermined, meaning you have more equations than you need, but that allows you to get a better solution. And then you have now your position, and then you have a small fix perhaps with respect to the time. And then that's how you keep doing this over time, and then you have now a set of locations.
Yeah, and is this what is called triangulation?
Triangulation. So
triangulation.
Yes. So I think that triangulation is like perhaps a very related problem, where you have one sender and then now a number of others are trying to figure out where that source of transmission is. While here this is
the opposite then.
The opposite, yes. So you have multiple sources, and now you are the one, and then you say, hey, okay, since I have these estimates of these distances from those guys, what is my X, Y, Z? And since just to connect now this discussion to the question by Eric, these signals, they are by design very low power, meaning the signal leaving the satellite by the time it arrives at somewhere close to the surface of the Earth is very low power. So it's very easy to disrupt. Of course, the design is such that it's not that easy, but if someone wants to overpower that transmission, that's trivial, if you wish. So you were discussing about jamming in a couple of episodes ago for wireless communications in general, and that's an excellent example. If you have a relatively cheap transmitter, you can, and you know how GPS or Galileo or your choice of GNSS works, you can very easily prevent my smartphone, your smartphone, Eric's smartphone from, for example, computing its location just by blasting enough power within a radius. And then you don't need any expensive equipment to do that. And that's not something that is possible only now, but for quite some time we know that. And funny enough, people are discovered an application for this. They buy their own small personal jammer, so that devices with GPS, for example, around them no longer work, and then they can drive, for example, their car wherever they need without that car recording location. So you see that this is a real and present issue with security for GNSS. But Eric, you also mentioned spoofing and other attacks. Would you like to discuss a bit more about those?
Yes, perhaps you could, for the benefit of the audience, explain the distinction between, on one hand, jamming and spoofing and possibly other attacks that can be made against GNSS systems.
So jamming is, the definition is the same as you gentlemen would define it in any wireless communication system. Essentially, you create interference that prevents the receiver from successfully decoding whatever transmission it is supposed to decode. So there's a signal coming, what you call a navigation, part of a navigation message, and that receiver won't be able to get the information from the satellite altogether. It won't be able to estimate its distance. It's prevented from doing what's supposed to do.
So the jamming signal could be, in principle, anything, right? That
yes.
At least looks sufficiently different from the GPS signal. In principle, you could use noise-like signals for jamming.
Absolutely. And then there were cases recently, the last few years, that some new technology was to be deployed, and it wasn't thought of before, but it would interfere with GPS in the areas of deployment, and then people had to just go and think it over, and it was inadvertent. Or there are cases of outages. Someone does an experiment, and then all of a sudden GPS receivers in a given region are not functioning while that experiment takes place.
So that is jamming. Would you also want to explain spoofing and the other attacks that these systems might be susceptible to?
Yes. So knowing how a global navigation satellite system works allows you basically to even design your own transmitter. You are not a satellite any longer, but you can be somewhere knowing how these signals are crafted and create your own version of them. And now you can transmit those, and you can hope that the receiver, the victim, because that's what you're trying to do. Let me explain why would you do such an attack, right? You're trying to convince, quote unquote, a given receiver that its location and time is what you are telling it to be, not what it is with respect to the satellite system it uses. So you create your own signals and you send them over, and if that victim or your target receiver locks on, meaning starts receiving your signals and believing that it is the satellite signals and starts computing now based on the information you are feeding it, then you succeed. So spoofing essentially means generate signals, pretend to be the satellite, look like the satellite transmissions, and then dictate to the victim their location and time.
So someone out there transmitting a signal that looks as if it came from a legitimate satellite, but which is actually forged and causes the GPS or GNSS receiver to believe that he is somewhere else.
Yes. And there has been such technology developed for good purposes, trying to basically test receivers and applications. But it also comes out with a cost. It also, there is, significant complexity in such an effort. But this doesn't mean that an attacker that doesn't have this capability, has nothing else to do. It's not jamming or spoofing. There is something else that attackers can do. They can try to record signals from the actual satellites and then replay them, or even relay them to another part of close to the surface and then retransmit them. And then they don't have to invent anything, they don't have to forge anything. But now these signals, if they're the ones that the receiver locks onto, they will be telling the receiver where it is. And you can see the picture, right? So I record signals here in Stockholm, I transmit them to, I don't know, let's say, I don't know how far you would like it to be, but let's say Göteborg on the other side of Sweden, and I retransmit them. If I'm successful, and if the receiver now believes that this is the actual transmission from the satellites, and it basically, that's what it operates on, it will basically think, even though it's roaming in Göteborg, it will think that it is in Stockholm. I'm simplifying, but I just want to show why this is an issue.
So basically a specific form of spoofing, right? That rather than forging a GNSS signal from scratch, the attacker records a legitimate signal and just delays it in time and then transmits it at a later point in time, but perhaps with a higher power so that it overshadows, the legit signals.
Absolutely.
Fascinating, yeah.
So are there solutions then? I think you touched upon that you could implement spoofing, for example, to test your receiver. So is there work or good solutions that you could utilize to protect ourselves against these type of attacks?
There are solutions at different points, at different parts of the system. So one approach is to implement a number of tests, let's say, on the receiver. So, for example, you can check whether the received power is even what is expected, given that you know how a signal would look like. Or you could look at that's what we call power test. If a signal is too strong to be a satellite signal, then you can reject it. Or you can look at properties of the signal. For example, something is called the Doppler shift. Depends on what's the relative motion of the sender and the receiver, and what happens to the frequency, and then determine whether this is something that corresponds to really to a transmitter and a receiver transmitter, which is really a satellite, and is moving that fast. One can keep going like that, but then now the interesting thing is that if you're a sophisticated attacker, you could possibly try to work around such tests by changing or fabricating, forging your signals appropriately. It's not easy, but let's say that's one way to go.
Yes, that also becomes a bit like a cat and mouse game there, yes. It seems. So the solution that you're mentioning, are these software solutions only, so that we can essentially say that, now there is a new version of our firmware for this device and we get a better protection in the Bluetooth, the GNSS interface? Yeah,
well, I think it depends how you want to go about it. So, for example, yes, you can redesign the receiver or augment it. That was our earlier vision about it. But then you can also think, if you have the ability to change the hardware, for example, so use multiple antennas, so that you can, for example, determine where the signal is coming from, the angle of the signal, and then infer whether this could be a satellite or it is, let's say, someone in the vehicle behind you transmitting. I mean, you could even try such an approach, or you can, if we stay in the original, say realm of solutions, meaning how do you augment the system, or how do you utilize capabilities that are there already. For example, you can try to obtain precise time, not perhaps as precise as the GNSS time, but precise enough time from other sources, because you are connected to a number of other networks, and compare this to the time that you get from your GNSS or perhaps the adversarial GNSS signals. And if there is a discrepancy, that could be a reason for you to detect the attack, right? That you are under attack. Or you can invent a number of statistical tests on the receiver that again will help the receiver declare, raise a flag and say, oh yes, I think I am under attack currently. That's one significant step. It doesn't tell you which of the signals are forged. It could be all signals that are forged, and detecting the attack is enough. But you could even go one step further. You can try to not only have this fault detection, but have some sort of exclusion. So you have a lot of signals out there. Perhaps there are multiple constellations, and now we have devices that do that. And then using this, let's call it redundant or rich information available, you could even try to tell which of those spoofed signals, which of those signals are spoofed, as Eric was describing before. And then if you manage to get rid of them, then the remaining signals, you hope, will be giving you still a reliable or trustworthy, even better, location and time. So you can keep augmenting, let's say, the system and then trying to build on functionality of the GNSS per se and bring in capabilities from the side, from other systems, perhaps a bit opportunistically, if you have that information, and protect the receiver as much as possible.
I see. So there seems to be a variety then of solutions that I guess one can apply in a smartphone or laptop or devices with a lot of computing power or a good battery and things like that. So if we switch, I think you talked earlier about IoT devices, for example. I was asked a few months ago to give a lecture about Bluetooth, and I realized when I was reading up about that topic that there are all of these sort of issues that are appearing when you are considering IoT devices, where you, in order to bring down the energy consumption and make everything as lean as possible, it seems like you are exposing yourself even more to threats. Can you say something about that?
Absolutely. So this is a very valid observation. So we can, if I can rephrase what you're saying in the context of security, it's like, how can we do security on a very low budget, meaning you have limited processing power, you have limited memory, you have perhaps even more so limited physical protection for those devices, and at the same time you might have, even though there are very significant advances, relatively speaking, you have even limited bandwidth. So combination of those make the solutions very difficult or more difficult to design and implement. At the same time, make it more easy for an attacker to overwhelm or compromise those devices. So let's look at one example. Let's say I want to have authentication of the messages that are being sent. I even want to have non-repudiation, meaning I want to prevent someone from sending a message and then, avoiding being held responsible for a given message, which means I need to use public key cryptography for that. If I operate on a battery and I have to do it for several messages per second, for example, it will be only a matter of time until I will run out of battery. Then how would I go about it? I can change the type of cryptography I'm using. Can use symmetric key cryptography. It's much more efficient. Great. Now, what happens if someone has access to my Internet of Things device? They extract the keys that it's using to transmit information and authenticate it or even encrypt it. Then they put themselves somewhere else in the network and just collect this information freely, let's say, from that device. So what do I do? How do I fight back? How do I refresh these keys? So it's difficult. What about the limited processing power and someone that comes and doesn't have to break into anything, that just needs to transmit at just a reasonable rate, forcing my devices to validate messages. Just try to figure out whether they are authentic or not, right? Then if you put enough load on those devices such that they cannot catch up processing all these messages with the CPU power, the processing power they have, then all of a sudden you do perhaps something that doesn't look wrong from the outside, but these victim devices, they're out of the picture, right? They will not be able to operate. It's what you would call a clogging denial of service attack. And you don't need to send too much traffic. It suffices to send enough for them to not be able to catch up because they're limited in power. So I'm just painting a little bit the picture of that you hinted about. Efficiency, denial of service resilience, security on a very low budget are significant challenges.
Yeah, so if we are imagining a wireless future with billions of IT devices, if people say, we would like them to be very lean on energy consumption so they can have a battery lasting for 10 years, then it's sort of part of the underlying assumptions there that they will be more susceptible to all of these type of security issues. Is that the right conclusion?
It is the right conclusion. Of course, there is hope in a sense that knowing about these challenges, we can build solutions that try to mitigate such attacks. So basically, we can eradicate the risks. For example, you start by building the appropriate trust management that can scale to these numbers of billions of devices deployed. Then you build security protocols which are lean, meaning they're frugal with what they ask. They could use expensive primitives, but rarely, but on the other hand, are as efficient as they can possibly be. You can even build denial of service resilience features in how you basically treat all this offending or overwhelming amounts of traffic, so that you can quickly figure out which parts of that traffic are the legitimate and the useful ones, and then weed out as much as possible the rest, and eventually let it expire and be no longer relevant and keep operating. You raise the bar in that sense. These approaches can definitely help, and hopefully there will be also some parts of the system which are more powerful, perhaps not all the billions of the devices, but they're more trustworthy, and by trading off some extra resources, some stronger designs, along with the very careful designs I was describing before, then we can get pretty reliable and trustworthy large-scale wireless systems. I mean, that's what we are striving for after all these years.
Yeah. But it seems like there is work to be done for communication engineers for many decades to come in these areas. Eric, do you have any more questions?
Not really. I mean, I think we covered lots of ground, and it's been an insightful discussion, Panos. It's on one hand somewhat alerting and scary to hear about all these new emerging threats, but it is also, as you suggested, Emil, probably good news. I mean, for those working on research and engineering in the wireless, field, that there are ample of challenges to address for the future. So with that, I think we are approaching the close-up here. So thank you, Panos, for being with us today.
Thanks.
And thank you, Emil. And thank you to the audience. Please, as always, feel free to send us feedback or questions that we can address in future episode. And don't forget to like and subscribe us on YouTube. Bye-bye.
Thank you.
Thank you. Bye-bye.